Thank you, viewers and learners, wherever you are. Also, another moment that we are still looking at simultaneous equations, but we are looking at solving simultaneous equations this time round using substitution method. Now, before we go deep, we delve deep into the substitution method. First of all, let us understand what are simultaneous equations again. And we said simultaneous equations are just equations. They can be linear or nonlinear, and they have two or more variables, two or more unknowns. Now, the value of the variables in both the equations that you have been presented with must be equal in both the equations or in both the system of equations that you are presented with. Now, depending on the system of equation presented, we established that there are four methods of solving simultaneous equation. Last time we looked at elimination method. Today we are going to look at substitution method. There is also augmented matrix method, or solving using matrices, and there is graphing method. Now let us delve deep into the substitution method and see how it here is used. Now, in substitution method, this one involves making one unknown the subject of the formula, then you equate it in the second equation. You use one equation, you make one unknown in that equation the subject of the formula, then you equate it in the second equation. So you don't equate it in the equation that you have used, you equate it in the second equation. We can look at an example. You have to solve for the value of x and y in the following system of linear equations, that is 2x plus 3y equals to 60, then x plus 2y equals to 35. Now, looking at this system of equations, we can choose among these two equations which one is easier to make it the subject of the formula. And we can call this one equation 1 and this one equation 2. So equation 2 is easy to make it the subject of the formula. So what do? We take equation 2 and make x the subject of the formula. So when you take equation 2 and with it you use it to make the subject of the formula, then it ends up with subtracting 2y from both sides, and then you end up with x equals to 35 minus 2y, because we subtract 2y from both sides. That is, we are using equation 2. Now, we found the value of x. So this value of x, we are going to equate it in equation 1. So you have to note that we used equation 2 to make it the x the subject of the formula, so we cannot return the value of x back to equation 2. We return it to the second equation, which is equation 1. So you equate the value of x in equation 1. Now, we have equation 1 as 2x plus 3y equals to 60. So it goes ahead and we have 2x, then the value of x is 32 minus 2y plus 3y equals to 60. So you end up with the 70 minus 4y plus 3y equals to 60, which translates to negative 1y equals to negative 10. Divide by negative 1 both sides, and you end up with y equals to 10. So after establishing that the value of y equals to 10, we can equate this value of y either in equation 1, equation 2, or we equate it into the value of x. And we find that equating this one in a equation 1 or 2, or in the value of x, that is equation 2. So you have x plus 2y equals to 35. So it means that x plus 2, then you put the value of y, which is 10, should give us 35, which translates to x plus 20 is 35, and this one translates to x equals to 15. Therefore, we have seen that we have established the value of x equals to 15 and the value of y equals to 10. And this is how you do solve system of simultaneous equations using substitution method. We can go ahead and look at another example that we are using substitution method. This one says that solve for the value of x in the following system of equation. We have 3x minus 5y equals -9. Then 5x plus 2y equals to 16. So we are going also to call this one equation 1 and this one equation 2. Going ahead, we are going to take equation 2 and make x the subject of the formula. So taking equation 2 and making x the subject of the formula, that means we are going to subtract 2y from both sides. So you are going to subtract 2y from both sides and you end up with 5x equals to 16 minus 2y. At this particular juncture, we divide by 5 both sides. And when you divide by 5 both sides, you're going to end up with x equals to 16 minus 2y divided by 5. So we have established that the value of x is 16 minus 2y over 5. So the value of x, we determined it from equation 2. So we have to equate it in equation 1. So when you equate the value of x in equation 1, it becomes 3, that is into bracket 16 minus 2y over 5. That was the value of x. Close the bracket, minus 5y gives us -9. Multiply both sides by 5 and you end up with this. Solve this one and it translates to y equals to 3. Now after finding the value of y equals to 3, you can either equate it in equation 1, equation 2, or the value of x. Now, so you equate the value of y in the equation of x. So the equation of x becomes 16 minus 2y, which is 3, over 5. And this one gives x equals to 2. So therefore, we can see we have established by substitution method that the value of x is 2 and the value of y is 3. And that is how substitution method is used. Going ahead, you can try 2 sums to do with substitution. Solve the following systems. The first one is 4x minus 2y equals to 10, then 2x plus 3y equals to 1. Then the second system is x plus y equals to 5, 3x minus 2y equals to 0. So solve for the value of x and y in those systems of simultaneous equations. Thank you for watching and learning. You can subscribe to my YouTube channel, Ombisi Online Math, or my Facebook channel, Ombisi Online Mathematics. Be blessed.